Okay, in this video we're going to be modeling parabolas based on some story problems. Okay, so for a jackrabbit to clear a 3-foot high fence, the rabbit must jump at its starting point 4 feet from the fence, sketch a situation, graph it, and find the equation. Okay, so I know it's a 3-foot high fence and it starts 4 feet away, and it's probably going to land 4 feet on the other side since we're building this parabola. And he's jumping. Okay, so when I do this point, the x value is 4 up here, and the y value is 3 up, so I went right 4, up 3, so there's my 4, 3, and we start at an initial 0, 0 because it hasn't jumped at all or moved anywhere. So if I graph them, it starts at 0, 0, and then right 4, 1, 2, 3, 4, up 1, 2, 3, and then he lands 4 away. Okay, so there's my generic picture. Now, that is going to be my HK for my vertex. So I got y equals a x minus 4 squared plus 3. There's my HK. But I need to figure out how much it stretches or compresses because it's not a 1, 3, 5. So I really need to solve for this a to figure out my true equation. So another easy point to plug in to solve for that a is going to be that starting point, that 0, 0. So 0 equals a, 0 minus 4 squared plus 3. I'm going to do my orders of operations, or my PEMDAS. So 0 minus 4 gets me negative 4 squared. Negative 4 squared, because my exponents come next, gets me a positive 16. We subtract 3, get rid of the things not attached to the a first, and then get rid of the thing attached to the a. So my a is negative 3 over 16, or the decimal form of it, and then I'm just going to rewrite my generic equation with my h and k, or my vertex. That should say a 3 in there. So then I could figure out if I wanted to plug in more points to see where else it would hit at, I would be able to plug them in for x and y. Okay, my next one, when Ms. Brown kicked a soccer ball, it traveled a horizontal distance of 150, and it reached a height of 100. At its highest point, sketch the path. Okay, so all the way across is 150, but halfway is 75 and then 100 up. Okay, so then this, we have our 0, 0. Okay, because 150 is the whole thing, but halfway is going to be 75. So we're going to do the same thing, but I'm going to use the 75 and 100. So I've got y equals a x minus 75 squared plus 100. We're going to plug in that 0, 0 because it's an easier initial starting. Oops. We're solving to see which it's stretching. So 0 minus 75 squared plus 100. So 0 equals a times negative 75 squared plus 100. So 0 equals 225a plus 100. Ooh. A step ahead, that's actually a bigger number. It is 5625. So we subtract 100. Divide by 5625. So I got my a to be negative 4 over 225. So rewrite the generic formula with the y and the x back in. So negative 4 over 225. X minus 75 squared, and I ran out of room again. It's supposed to say plus 100 back there. So that would be my generic equation for this u. Okay, my next one is the skateboard park. A hot new attraction is the U-dips, a cement structure embedded in the ground. The cross-section view of the U-dip parabola dips 15 feet below. The width of the ground level is, at its widest part, 40 feet across. So I know it's 40 feet. So from left to right, it is 40 feet. I know it goes 15 down. And since we are going down, this is actually going to be a negative 15. So this point, remember, is halfway. So my x value is 20 because I'm still going right, but I went down 15, and they're initially starting at that 0, 0 again. So I've got y equals a x minus 20 squared minus 15. We're going to plop in that 0, 0. 0 equals a times negative 20 squared minus 15. 0 equals 400a minus 15. I add 15. 15 equals 400a. Divide by 400. So I get simplified as 3 over 80. So y equals 3 over 80. Okay, it's positive this time. That gives us our happy face u. That's that curve down. X minus 20 squared minus 15. Okay, my next one's going to be a little trickier. While watering her outdoor plants, Mara noticed that the water coming out of her garden hose followed in a parabolic path. So it's still going to shoot off like this. Thinking that she might be able to model the path of the water with an equation, she quickly took some measurements. The highest point the water reached was 8 feet, and it landed 10 plants from the feet from where she was standing. Both the nozzle and the hose at the top of the flowers were 4 feet above the ground. This is where it gets tricky. Sketch a graph and find an equation that describes the path of the water for the hose to the top of the plants. What domain and range makes sense for this model? Okay, so it says the highest point of the water was 8 feet. So I know that y value is going to be 8. Okay, the highest point in the water was 8 feet. It landed on the plants 10 feet from where she was standing. So from 0 to 10, I know this is 10 feet. And she was already 4 feet above the ground. So this one's a little weird. She's already 4 feet up. Okay, so that means this one here is going to be 0, 4. And now we need to add, instead of it really being 8 feet high, we're going to make it 12 because we just added 4 on top of it. Okay, so all the way across is 10, so now I've got this to be 5. So this time instead of 0, 0, I'm plugging in 4, 0. So I've got 4 equals a 0 minus 5 squared plus 12. So 4 equals a negative 5 squared plus 12. 4 equals 25a plus 12. Subtract 12, you get negative 8 equals 25a. Divide by 25, a equals negative 8 over 25. Okay, so your equation then, if I could find some space here, so y equals negative 8 over 25, x minus 5 squared, plus 12.